But he's gonna jump in the video. Like I tell y'all, the grind don't stop. The grind don't stop. You gonna keep grinding.
There's a new way to own gold. Introducing digital gold from Wisdom Tree Prime with direct ownership.
Afternoon, folks. I'm Dave Canterbury with Silver Lines Outfitters
Shouts
in
to
the
Dave
Pathfinder School. I'm
Canterbury.
back down here at the Pathfinder Outdoor Classroom. Back in another segment, 10 minutes to better land navigation. Throughout this series, we've talked about different ways and different tools that you can implement to be a better navigator, to be a master navigator over land with a map as well as without a map. We're going to talk about some electronic tools down the road in this series as well. What I want to talk about today is I want to continue our video from last week on latitude, longitude. And again, the reason that's so important is because if you're being rescued by air or water, most of the time they're going to require lat and long coordinates in order to find you. And as long as you're close and you can estimate that, you're most likely going to be found, no problem. But today I'm going to show you how to get more exact with that by carrying a measurement tool with you that can also double as a protractor. So you can carry the one tool and you can get several things done. As long as you understand how to use your compass rosette to turn your compass into an actual protractor to find angles, you can use this singular tool to be able to plot grid coordinates for UTM or to figure out your lat long. So let's get started. Okay, this is a tool from maptools.com.
Get your compass, y'all.
Made for measuring
this is very important.
And you
a compass and a map is very important for land navigation. We already
talked about the reason for that 1 to 10,000 scale. And right away you can see that there is a centimeter measuring device on here that goes to 1,000 meters or 10 centimeters, okay, or 1K. What that allows you to do is use this device with a 1 to 10,000 map to get an 8-digit grid coordinate very easily so that you can get some type of rescue or something like that for ground forces, or get a grid coordinate that's within 8 digits, which gets you within 10 meters of a target. Now, looking further on this tool, we also have on the flip side, nautical miles, which that doesn't matter if we're not using a water map. On the flip side of this, we have two scales. We have one that is in 0.01 minute intervals, and we have one that is in 1 second intervals, okay? The seconds interval is the one that we're going to use on our map to be able to figure our lat long. Let's talk about that. Okay, if you remember right, our longitude are the lines that run north-south on the map, but they're running degree-wise and minute-wise east to west, okay? So what we have here is 82 degrees, 30 minutes, 45 seconds. And as we go west, away from the prime meridian, they increase. So every 15 seconds, here's 31 minutes and 0 seconds. So they're increasing as we go west for longitude. Our latitude lines that run east-west or west to east, however you're looking at it, are actually going north on the map. And they are starting at 39 degrees, 2 minutes, 15, and increasing as we go toward the pole. So now we got 39.230, 39.245, 39.3, all right? That's important to understand. Now, the next thing we need to understand with this is when we draw these lat long boxes, you can see where we intersected here on the last video. If we took another reticule right here and drew it in, and we actually made a box here, it would not be a perfect square, it would be a rectangle. The reason for that is 15 seconds of latitude and 15 seconds of longitude are not exactly the same, and they change depending on how high you are in latitude. For that reason, these are evenly spaced in longitude. The latitude is what changes and makes the box more of a rectangle. So what we need to understand is that this one measuring system will work for both, but it can't just be laid on the map flat on the line to work. An example of that, to show you that, is if you look at the reticulate here at 31.0 to 30.45, that's 15 seconds on that map. If we lay our device on there that's in seconds between those two, what you're going to see is you're going to see about 11 or 12 seconds right there. About 11 3/4 seconds right there, because it's not going to be a square. Whereas if you went from the latitude lines here on your graticulus, it would be exactly 15 between graticulus. Right, here's one graticulate, here's another. It's just that little bitty line right there. It's not the grid square. It's that little bitty tick mark is the graticulate. Up to the next one is exactly 15 seconds, okay? So you have to use this tool 2 different ways to get your readings. All right, so what I've done is I've closed in these graticulate grids for you so you can clearly see that these are rectangles. But remember that there's still 15 seconds from east to west and 15 seconds from south to north. Even though the distances aren't equal, the seconds are. So they do not equate. For that reason, you have to use this measuring tool 2 different ways. Remember that when we were measuring latitude, the measuring device showed 15 seconds laying flat against. So if we go here, we can measure straight up and down just like this to get our seconds that we're going to add. So if our line here in latitude is 39,230, and the next one's 45, that's 15 seconds. We just need to add, you can see that 15 seconds lines up right at the top. So we just need to add 1 second for every mark. So we go 230, 31, 32, 33, 34, all right? So we're 39 degrees, 2 minutes, 34 seconds north latitude. Now, when we measure our longitude, we're gonna have to measure at an angle because again, we don't have the same distance there in all actuality. So what we have to do is we have to put the 0 line at the corner where the graticulate cross, the closest to our target. And then we have to angle this so that we get 15 seconds touching the graticulate to the west. So that we're touching the crossing and the 15 seconds on the graticulate at the same time until we are under our target as well, just like this. Then we would count our seconds. So we would start at 82 degrees, 30 minutes, 45, 46, 47, 48, 49, 50 seconds west longitude, all right? So again, we start at the corner with the 0 mark. We rotate up until we get 15 seconds to touch our other graticulate to the west, because remember, this span is 15 seconds. So we're making this simulate 15 seconds. And then we just need to count the seconds up. In this case, it's a little more than 5, a little less than 6. So I just rounded it down to 5. And that's going to get us within 1 second of our longitude. All right, guys, so that was just another quick segment in our 10 Minutes to Better Land app, explaining how you can use.
Thank you guys for watching. Don't forget to subscribe, hit that thumbs up, and click that bell. Shout out to Dave Canterbury. So I'm gonna let him finish.
Is an actual measuring device to find your latitude, longitude within about a second. Now, again, if you're within 3 or 4 seconds, you're going to be very, very close. And you can measure that, figure out how much that would be off. But on our map, we've looked at that and we figured out that if you're within 5 seconds, you're within about 140 meters of the target. So if you're only off 2 or 3 seconds, you're going to be very, very close for someone rescuing you by air or someone looking for you on the water. I appreciate your views. I appreciate your support. I thank you for everything you do for our school, for our family, for our business, all of our sponsors, instructors, affiliates, and friends. And I'll be back with another video as soon as I can, guys. Thanks.
Peace.